So, since you broke my triangle, I deserve a little conversation and money, or I'll eat your flesh. What we gonna do? What we gonna do?
We don't have like money, but we have this.
I think I might know someone who can help. You have come, my child. I know what you want. You want answers, and I can provide. Owen and Dylan entered a friendly competition to see who could throw a ball the highest and farthest. Owen and Dylan were throwing the ball from a platform that was y equals negative 0.25x squared plus 1.5x plus 4, and Dylan was y equals 1.5x squared plus 6x plus 4, where x is times in seconds and y is height in meters. A. Make sure to use a different strategy for each equation to find the maximum height and farthest distance. B. How long was the ball at 6 meters for both Dylan and Owen? What? I'm not doing all that. Why can't you just tell us? Us child, I can only tell the future in math. What?
It's okay. We can do this. Let's do math. Step 1. The equation ball thrown by Owen was y equals 0.25x squared plus 1.5x plus 4. You can use the quadratic formula to find the y-intercepts. We need to find the y-intercepts in order to find the vertex. The vertex will give us the peak of our parabola. The quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a, where a equals minus 0.25, b equals 1.5, and c equals 4. Sub in the values to the quadratic formula and then solve. Solve what is under the square root and what is the numerator. Solve for plus or minus and square root. Find the midpoint of these x-intercepts, aka the axis of symmetry, AOS, and then the x-point of the vertex. We could use this formula to find the midpoint, x1 plus x2 over 2. Now plug in the AOS of 3 into the given equation. Submit 3 into x to give us the y point at the points x.3. Our answer. Owen, maximum height was 6.5 meters at 3 seconds. See his graph for example. We can solve for the vertex another way by completing the square of the given equation. This will give our equation from standard form. 0 equals ax squared plus bx plus c, the vertex form. Y equals a bracket x minus h squared plus k, where h represents the x value of the vertex and k represents the value of the vertex. To complete this here, we will first factor out a from b, which is here is minus 1.5x. Then take b or minus 4 and then divide it by 2 and square it. Step 4 into the bracket. Make a zero pair to keep the equation the same. Factor out the perfect square of the square root of x squared minus 2x plus the square root of 4. Times by 4 by the a value, minus 1.5, by distributing a in order to balance the factoring out of a to complete the square. Combine like terms. Answer is 210, so Dylan's maximum height of the ball was 10 meters at 2 seconds. We use the quadratic formula and repeat these steps to find the peak of Owen's ball to see the distance and time the ball was hit the ground. See graph as example. Compare. Dylan threw the ball higher, but Owen threw the ball farther.
Can we just go now? We know the answer. No, you need to solve our part B too. Fine, I'll do it. Step 1. How long was the ball at 6 meters? We can find this out by setting our equation of y equals negative 0.25 x squared plus 1.5 x plus 4 to equals 6 to find the intercepts to this equation when y equals 6. This creates a horizontal line at the y-point 6. When we calculate the intercepts of the parabola to this line, it will give us the coordinates when y equals 6 on both sides of the parabola. Step 2. Move 6 over the equal sign by subtracting 6 by both sides. Step 3. Find the x-intercepts of this equation by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a, where a equals negative 0.25, b equals 1.5, and c equals negative 2. Then solve as we did in part 1. Therefore, for Owen, the ball was at the height of 6 meters for about 2 to 4 seconds. See graph as example. Repeat this process and the same steps for Dylan with the equation y equals negative 1.5x squared plus 6x plus 4. You can pause here so you can do it yourself. Repeat this process and the same steps for Dylan with the given equation y equals negative 1.5x squared plus 6x plus 4. You can pause the video here so you can do it yourself. Repeat this process and the same steps for Dylan with the given equation y equals negative 1.5x squared plus 6x plus 4. You can pause here and see if you can do it yourself. Answer. X equals 0.4, X equals 3.6. Answer. For Dylan, the ball was at a height of 6 meters for about 0.4 to 3.6 seconds. See graph example. Good work. You're free to go.
Yes!
All right.